Another line of research, this one based in physics, complements and reinforces the conclusion suggested by emergent computation and artificial life. Physicists Per Bach and Kan Chung have studied a process they call self-organized criticality. They use a pile of sand as a simple example. As more sand is added to the top of the pile, grain by grain, the sides of the pile will eventually reach a limiting steepness. When more sand is added, the slope of the sides will become too steep, and landslides will return the sides to a more stable slope. As the process of adding sand continues, landslides of all sizes will occur. Most of them will be very small, some will be larger, and a very few will be catastrophic. The relationship between the size of the landslides and the frequency with which they occur follows a precise mathematical law called a scaling relationship. And if we keep a photographic record of all the landslides and superimpose them on one another, little ones on top of big ones on top of even bigger ones, we'll see that the surface of the sand pile is covered in a fractal pattern. These patterns, as we'll remember, are similar to themselves at all scales of magnification. Patterns within patterns within patterns. Because of this fractal ensemble of landslides, the sand pile maintains an overall form that is just at the limit of stability. This is the origin of the name self-organized criticality. Bach and Chung explain how the slopes always return to a critical state.
The most striking feature of the self-organized critical state is its resilience. The system responds to any perturbation, randomness, and so on by returning to the critical state after a transient period. If snow screens are added in an effort to prevent falling sand, the pile simply builds up to a steeper critical state, thus completely counteracting any effort to take the system away from criticality. Could this be the explanation for the resilience of biological, geological, and economic systems?
Self-organized criticality seems to appear in many situations. For example, in many sectors of the economy, the number of firms in each size category tends to remain constant, despite a never-ending series of startups, mergers, and bankruptcies. Other research has shown that earthquakes also follow the patterns of self-organized criticality. So these patterns occur not only in the activities of mankind, but also in the very structure of the natural world.